Welcome back to section 10.4. In this video we're going to do a comparison of three different shapes. So this is actually for a popsicle stick bridge project that I have students do occasionally. And one of the things that they run into is a buckling analysis, that they find that stiffness is important. Stiffness is in the buckling equation. So I have them so we go in class, we do this example, and we're going to do it right now. And we look at how stiff is a beam, and then I can make it more stiff by just doubling its thickness, but I can probably be more strategic about it. And so that's why we look at example C here. So this asks us to find the moment of the area moment of inertia about the centroidal y-axis. So centroidal y-axis means that for these shapes I do have to find the centroid first. Now, conveniently, they're all symmetric, which means I don't actually have to do any math. I just know that it's right down the center for all of these. But if I did not know where it was, or it wasn't obvious, like due to symmetry, I would have to calculate this first. All right. So for A, this is just a single popsicle stick turned up on its edge. Pretty common for a craft stick bridge. So what is the stiffness of one of these? So I can calculate this by just assuming it's a rectangle. It's not exactly a rectangle, but it's pretty close. And so IY, so this is about the centroidal axis G, so we actually can just use their equation straight from the book. So it's 1/12 height base cubed. Height base cubed. Again, these equations are in the back of your book. So if I put all this in, I will have 1/12. Our height is 3/8 of an inch, and our base is 1/12 of an inch. We're going to cube that last one. So if you plug all that into your calculator, you should get 18.08 e to the negative 6 inches to the 4th power. Okay. So that would kind of be like your bare minimum box stock. So what happens if I just add another stick on here? So I'm just like, oh, we're just going to glue another stick on here and call it a day. So now our centroidal y-axis is no longer here. It actually moves over to this line where I glue them together. So again, find the centroid first. So in this case, IYG. So this is still a rectangle. So I can still use the same equation. I'll just put in different numbers. Height base cubed, so 1/12. My height is still 3/8, and my base is, now it is 2/12, because I've doubled it. Now, immediately you should see that the way the equation works, it would be really nice if we could just turn this thing sideways, right? That's what hopefully it's what you think. And that would be true. We would have a very high IY then. But we would find that IX would basically be this number, whatever we get here. And the way buckling, at least the equations that we would use for the class, it would just default to whatever the lowest one is. So it wouldn't actually make the beam any stronger. It'd make it stronger bending about the Y, but it wouldn't make it overall stronger. So this would still be the weakest axis. Basically, this is larger than this, so it's more likely to bend about the y-axis than the x-axis. We put these numbers into a calculator, and you will get 144.7 e negative 6 inches to the 4th. All right, and then how about C? So C is actually two different things. We can't just use our rectangle anymore. So I would do composite bodies here. So let's just set that up real quick. So we have a shape. So I don't even need a number of these. I'll just draw them. A little bit easier. And what I want to know is what is their IYG. And then I'll look at their area and their distance. But what we're going to find is that so this is, we can probably agree this is symmetric about this axis. The centroid of this one is here. The centroid of this one is here. So our distances in both cases are going to be 0, so I don't even need to find this. So literally, if I just find IYG for each one, and I sum them up, I'll be in good shape. So for this one, we're going to get 1/12 base height cubed. Sorry, height base cubed. Same equation all the time. So this is literally this shape. So I'll write it out real quick, but we already know the number. So that's going to be our 18.08 e negative 6 inches to the fourth. This one is going to be 1/12, and then we're going to flip these. So now we're going to put our 1/12 in here, and our 3/8 will go right here. We're going to cube that. So this is the shape, and I glue them both together. And then what I find is that this is a whopping 366.2 e negative 6 inches to the fourth. When I sum those together, I get a total of 384.3 e to the negative 6 inches raised to the fourth. So those are our numbers. Let's compare them real quick. So this is we just take a popsicle stick out of the bag, we glue it on, we call it a day. This is, we do a little bit of work, we glue an extra one on. It's not twice as strong, it's actually 8 times stronger. And that's because of this cube. So we doubled it, but 2 cubed is 8, so that's where that comes from. In this case, I was a bit more strategic about that. So again, if you kind of think about the way that, kind of look at that parallel axis theorem again. So Iy equal to Iyg plus AD squared. So if I could kind of take a box stock thing, I want to put my area as far out as I can. So if I had the choice between doubling my area and doubling my distance, I would double my distance every single time because my distance gets squared. So my effect is magnified. And that's what we've done here, is we've taken the same amount of area, but I've moved more of it away from my central axis. So that's why this is really, if you understand the equations, then you can understand how to design using the equations. So it ends up that this is 21 times stronger. Well, I wouldn't say stronger. It's stiffer, whatever. Was 21 times larger. How about that? So its stiffness is much, much larger about the y-axis. In fact, it's so much that we'd actually want to check it about the x-axis, because if the x-axis is smaller, it might actually bend about the x-axis now. So 21, by looking at the equation and understanding how to use our additional area, versus 8 times by just being lazy. So hopefully that helps. Hopefully that was a little bit interesting. If you have any questions, feel free to reach out.